Good morning, LS and GS students. This is your math teacher, Miss you all. Hope you are all safe. Our lesson today is about relative position of two straight lines in space. They are confounded, parallel, intersecting, skew. This is what we are going to see in our lesson today. As I said before, the relative position of two straight lines can be parallel, confounded, and intersecting, and non-coplanar, or they are skew. How I can determine this? In fact, if we have two straight lines D and D prime, let R1 and R2 be their director vectors respectively, and A1 and A2 be 2 points of D and D prime also respectively. If R1 and R2 are collinear, how I can prove that two straight lines are collinear? Or by taking their director vector R1 equal alpha R2, or x of R1 over x of R2 equal y over y equal z over z. Or simply I can take R1 cross R2. If the answer is the null vector, then they are collinear. If not, then they are not collinear. But if they are collinear, I can deduce in this case that D and D prime are either parallel or confounded. So I can take a point from the first straight line A1 and I'm going to check up if it is a point of the second straight line. If it is, then the two straight lines are confounded. If not, then the two straight lines are parallel. But what if they are not collinear? In fact, we have also two cases. If the two vectors are not collinear, then D and D prime are either intersecting or non-coplanar. So how I can prove that they are intersecting or non-coplanar? Intersecting if they are in the same plane. So I can check up if they are in the same plane by taking A1 dot A2 dot R1 cross R2. If the answer is 0, then the two straight lines are coplanar, and since they are not parallel, then they are intersecting. If A1 dot A2 dot R1 cross R2 is not equal to 0, then D and D prime are non-coplanar and they are not intersecting. A special case here, if R1 dot R2 equal to 0, then D and D prime are orthogonal. As an example, we have two straight lines, as you see, x equal t plus 1, y equal t plus 2, z equal 2t plus 3, x equal minus m plus 4, minus m minus 2, z m plus 1. Here, if we take the two director vector of the two straight lines, we notice that RD dot RD prime equals 0, then the two straight lines are either perpendicular or orthogonal. What do we mean by orthogonal? They are held by perpendicular lines but from a distance. So I can take a system of equations formed of the value of x here and the value of x here, and I can write x equal x, then we obtain t plus 1 equal minus m plus 4, y equal t plus 2, y equal minus m minus 2, and 2t plus 3. So by solving the first two equations, we notice that this system admits no solution. Then in this case, I can deduce that the two straight lines are non-coplanar, then they are orthogonal. Not because they are non-coplanar, because they are non-coplanar and are of d dot r of d prime equal to 0. Another example, d1 equal x, x equal t plus 1, y, z, y equal t plus 2, sorry, I'm going to correct this, y equal 2t plus 1, z equal, and z equal minus t plus 2, and d2 equal, or x equal m, y equal minus m plus 2, z equal 2. So by taking, as in the previous example, t plus 1 equal m, 2t plus 1 equal minus m plus 2, we notice that we obtain the values for t equal 0 for value and y and m equal 1. If we replace it in the third equation, which is minus t plus 2 and 2m, we obtain a correct answer. So we can deduce that the two straight lines are intersecting. How I can determine the point of intersection? If we replace 0 instead of t here, we obtain 1, 1, 2, I, or by replacing 1 instead of m, we obtain also 1, 1, 2. Then their point of intersection is I of coordinates 1, 1, and 2. Now, what about the relative position of a line and a plane? In fact, a line and a plane, or they are parallel, or the line lies or is contained in the plane, or the line intersects the plane. How I can determine this? By using the director vector and the normal of the straight line and the normal vector of the plane, and by using the coordinates of a point A of the straight line. What do I mean by this? If R is a director vector of the straight line and N is a normal vector of the plane, then if they are orthogonal, what do we mean by orthogonal? R dot M equal to 0, then D is parallel to P or lies in P. How I'm going to check up if D is in P or parallel? I take a point of D and I'll check up if it is in the plane. If not, then the plane parallel. If it is in the plane, then the plane contained. If R and N are not orthogonal, so I can deduce directly that the straight line intersects the plane. Now, they ask us here to determine the point of intersection I between the plane P and the line D. We replace directly, I can take the parametric equations of the straight line D and I'm going to replace it in the plane P. Now I notice that when we replace it, we obtain T equal to, so then again I replace the value of T here. We obtain the point I, which is 3, 2, and minus 1, and which is the point of intersection of the two, of the plane and the straight line. Here another example. Here I have P equal x minus y plus z, and D equal x to t minus 1 yt, and z equal minus t plus 1. If we replace the coordinates or the parametric equations of D in the plane, we obtain 0, t equals 0. In this case, we can deduce that D lies in the plane. What about these two, this plane and this straight line? We notice here that 0t equal 2, which is impossible, because 0t must be equal to 0. If it is not impossible, then we can deduce that D is parallel to the plane. They do not intersect, and they are in fact parallel. Distance from a point to a line in space, I gave it to you when I gave you the vector product. I'm going to repeat it. Consider in a space a line D and a vector of director vector R, and let M be any point in the space. We take any 2 points A and B on D and let H be the foot of the perpendicular drawn from M to D. Then the distance from M to D is definitely MH, which is equal MA cross MB, norm of MA cross MB over AB, and this is the distance between a point and a straight line. We can take any 2 points on the straight line. Another example here, I have the point M and the straight line. So to determine any 2 points of the straight line, first of all we replace T by 0, we obtain A0 minus 1, 0, and T by 1 we obtain another point which is 2, 0, and 1. By taking AB equal radical 6 and MA and MB, I can say that their coordinates minus 1, minus 3, minus 2, and also 1, minus 2, minus 2. So we obtain MA cross MB equal 0i minus 5j plus 5k. If we take its norm, it will be 5 radical 2. Therefore, the distance from M to the straight line D, which is MH, equal MA cross MB, which is 5 radical 2, over AB, which is radical 6. Then this is 5 radical 3 over 3, and that's all for today. Thank you.